Okay, there we
Great.
go.
Okay.
Okay, so let me join from my phone. Unless do you have the link and you could join from your phone instead?
I could.
Okay. Okay, we're good now. Zeno's getting the phone
I'll
set up.
send it in an updated email.
No, it was in the chat.
Oh, yeah, I can do that.
Okay, let me just,
It is not the chat. Which chat?
it was in the chat for. Here, I'm sending it to you. All right, check your WhatsApp. Okay. Otherwise, Zeno's getting the like up close camera ready to go,
Okay.
and we're ready to start.
So let's quickly have you guys introduce your team, and we'll start with the nose cone.
Okay, so quickly introduce the team. This is three members. When Ashna joins, it'll be four of us. So Zeno and I are the co-presidents of the team. There was about, I think, 21 people exactly on the team that I've registered for the competition, but 12 of us are going. Owen is in charge of all recovery things, integration, and Ashna is in charge of airframe, and so kind of all the more like physical structural aspects. We have another member who might be joining, but he's waiting for a delayed flight. So if there's good Wi-Fi in the airport, who's in charge of avionics and more of the like all the details involved with the electronic parts. So I know how they all work overall, but I hope he comes that he can tell you more about the specifics. He made our launch system. We're really excited about it. So the team is mostly sophomores and freshmen. We're a new team. I'd say about half and half sophomores and freshmen at this point, with people who've kind of joined and left throughout the year. We're calling this our year one. So we got restarted last year. And because we didn't really do much other than restructure and understand how a rocket works, we were like, okay, that's year zero. This is year one. Now we're building a full rocket. Like last year, we kind of started, there's like pieces of our thing that we built last year. We use for like epoxy practice and stuff like that. But so we got very excited to be part of Spaceport this year. We tried to apply last year, but without real knowledge, it kind of became quickly apparent that it wasn't a good idea to be in Spaceport. So this year, everything's still pretty new to us, and we've kind of been working, except for having the rocket finished. All the other technical reports were kind of like, okay, now we're figuring out what to do a day or two before it's due, but like we got it all in. And you read all of our reports. Yeah, so it's kind of crazy that like the whole rocket is disassembled right here. We put it all like stacked it up before it was too tall to fit in this room. It's kind of crazy that we've just built something that is gonna launch and go 10,000 feet. We have a ground test that we're preparing, Owen and I think for this Sunday. We're gonna figure out logistics. We have to buy more black powder. But we're doing a full ground test to make sure that with the rocket fully assembled, that the charges still work. Yeah,
I'll take care of it.
Okay, thanks. And yeah, the rocket's clearly unpainted, but we're going to paint it after ground test once everything is like good to go. And the one thing for the rocket that we don't have physically with us is the motor. Because of university rules, we weren't allowed to bring it on campus, and we ended up buying through Animal Motor Works earlier this year, and it'll be there at New Mexico. So we're going to talk to our flyer of record about helping us get comfortable loading it, because that's something we've never done before. We've watched videos and practiced loading in the empty casing and all that type of stuff, but we actually haven't done a full launch yet. So that's the one thing I want us to do next year, is somehow find a way to do a full launch earlier, so we like are more sure of how the rocket is going to function as a full unit. But I think other than that, we've done almost anything that we could do as a new team.
Awesome.
Yeah.
Are you guys using a CTI or Aerotech motor?
It was a Cicerone motor.
Okay, so CTI, so that's running
Yeah.
technology.
Oh yeah, sorry.
You're fine. Awesome, home. I know I just built a CTI motor a month ago. The phenolic tube for their motor of my friends was manufactured wrong. Took us 7 hours to build a motor. Usually it takes maybe about 45 to an hour and a half, depending how big of the motor.
Mhm.
It was painful.
Okay, so we'll figure out how to get it as soon as possible and make sure we can assemble it properly.
Pretty much.
Yeah,
Okay, so let's start with your nose cone and
Okay.
how
do
you
it.
guys.
so I guess
Is
we'll
your
just-
whole entire rocket a COTS or commercial off the shelf tubing and nose cone?
Yeah, so we bought the
Okay.
kit last year. And so we had to rebuy a few tubes, but we used most of the kit because we didn't know how to manufacture stuff yet on our own. We're gonna
Mhm.
learn how to do layups either over the summer or starting next year. And depending on budget, buy more sturdy stuff or see what we can make ourselves. And I think the goal is to make as much as we can ourselves, but the school wants
Mhm.
us to buy stuff if we can afford it, so.
Okay.
Yeah, but this is all yeah, this is all COTS. We
Oh.
didn't manufacture any of the fiberglass.
Can I get the kit name and where you guys purchased it from?
Yeah,
If
it
you guys
was
have that
from, it
information.
was from Wildman Rocketry, and it was the Mad Dog 6 kit.
Thank you.
Yeah, so it's a metal tipped, I think it's aluminum tipped fiberglass. with it.
Yeah, that's usually aluminum tip. Let me pin Zeno's video so I can see it close up.
Yeah,
So, is that going to be the carbon fiber filament round nose cone
all,
or
I
that fiberglass?
think it's all fiberglass.
Yeah.
I think it's just black fiberglass.
Okay.
And it's a Von Karman, I forget exactly what number, it's 50 something, Ashna, do you know the exact? It was like 520s or it's 502 or something like that.
Give me a few minutes and I can pull it up.
Thanks. Yeah, thank you, Matthew.
Yes, thank you, Matthew.
Yeah, so Matt is the one who's in charge of avionics.
Mhm.
Yeah, and so if you, at the base of the nose cone, that red part is the coupler for the parachute. Oh, and I'm blanking. Are we doing the drogue or the main coming from the nose?
The drogue is on top. You got
The drogue is on top?
Mhm.
Okay, so yeah, the inside, the nose cone's full of our payload, so it's a little heavy. But inside there's a U-bolt to connect to the parachute, and so the red is already screwed in for that coupler. Do you need help with that, Zeno?
No, I got it.
Okay,
I have
So if you
the
can
nose
see-
cone. It's a Von Karman 521.
521, okay.
Okay. And the shoulder length is at least 0.5 calibers or greater for the nose cone?
So. We,
How long is the nose cone from the edge of the black to the tip of the coupler?
do you guys have that number off the top? Or do you have it in the report? I don't remember off the top of my head. Or we can measure it right now.
Apogee was very kind to send us this as part of our numerous purchases from them. This is a 6-inch ruler.
Do you want a measuring tape? You have one?
Vaguely speaking, it's 7 inches, but it's
And what's
around
the-
7 inches.
The shoulder is
What's-
about,
So that was a 6-inch roller, it's definitely over 6 inches.
Yeah.
That's definitely meeting the minimum of 0.5 caliber.
Mhm.
If your rocket outer diameter is 6 inches, the caliber should be 3 inches.
okay. And that means like how much of the shoulder there is sticking out?
Correct.
Okay, so, okay. Yeah, when we stacked it all, it was wobbly because of how tall it was, but not because of like lack of, there was a lot of overlap, so I wasn't worried that it would actually like fall apart. It was more just, we're holding
Exactly.
up this tall, unscrewed together so far, rocket,
Okay.
yeah.
And then how's your nose cone gonna be attached to the other tube?
With nylon shear pins.
Nylon shear pins?
They're
And
still
what
nylon.
size shear pins?
Oh, and what did, your volume's really low.
Can you hear me now better?
What was it?
Can you hear me better now?
Oh, yeah, now I can hear you better.
440s?
440 is okay. And how many?
4.
We've got
I
4
can hear you,
screws.
Owen.
4.
4 screws?
Yeah.
So that's for
Um,
both sections.
I know 440s are usually small. I
Okay.
would recommend if you do maybe 6 440s.
Okay.
Um, since they will be taking a lot of the forces of launch, they could easily already shear with the amount of thrusts leaving the pad.
Okay.
When you do go through your safety review at the convention center in Las Cruces, other safety reviewers will be doing your safety review. It won't be me, and everyone's different, and they might require more shear pins.
Okay. So it might be better to add more just to be safe.
Correct.
Okay.
And you can always verify that in your ground test to see if your deployment charges are big enough to shear all 6 shear pins,
Okay.
or
Good
as
idea.
many as you need.
Would
I
it?
said on one review, and they wanted to add 12, and we told them no, that's overkill.
Gotcha. Okay. And the ground test in Las Cruces, or not the ground test, the safety review in Las Cruces, we'll have the rocket assembled and people will be asking us questions before we bring it to the actual launch pad.
Correct. So
Okay.
the safety review in Las Cruces is just make sure everything is set to go. Because some teams are still manufacturing the rockets currently. So we want to make sure it's a final go ahead to see it visually and to inspect everything is ready to go in the rocket for launch. When you bring it to the convention center, do not bring any live motors in or live charges.
Right.
We pretty much want everything except for black powder, CO2 cartridges, or the motor in the convention center. So, and I know you guys mentioned black powder.
Mhm.
What are your grams of each charge well for drogue and main?
Owen, do you want to cover this?
It's fine. Is my mic better now?
Yes.
For Drogue and Main, both are gonna have like the primary and the backup charges. And each one right now we're gonna do 5 and 5. But we also haven't tested it with 6 440 shear bolts.
Okay.
But I imagine 5 and 5 will hopefully be good enough because we most recently did like 4 grams with like 3 440s. And those broke easily and had more than enough pressure when we tested them. So I'm assuming 5 for 6 should be good, or maybe even 6 grams, but right around there.
Okay. I would suggest for your backup charges, add at least another gram or and a half to it. So make it 5 and 6.5 grams. Just in case if the 5 wasn't big enough, the 6 to 6.5 should be more than enough to make sure it deploys.
Okay.
And then shock cores. What type of shock cores are you guys using?
We're using 1.25 inch nylon tubular webbing.
Awesome.
They're each 30 feet long, one for the drogue and then one for the main. And they both have Kevlar coating on one end, which will be the end closest to the black powder charge.
Awesome. And do you guys know about the 1/3 rule of tying the parachutes to that 1/3 rule on the shock cord?
Putting the parachutes 1/3 up the shock cord, or
Yes. The shock cord should be the attachment point where the parachute will be attached to. So let me get a chart. 1 second. Easier visual.
Thank you.
Thanks, Connor.
So when you deploy your shock cord, it's going to be 1/3. So let's say this end will be your nose tip. This end is going to be your other end. You want them to be at least 1/3 away, or the parachute to be 1/3 on one end away. So your nose or the 2 separate ends of the rocket will not be clanking on each other while it comes down on parachute.
That makes sense.
Makes sense.
And you have to make sure which side, the 1/3 or the 2/3, is on the separating end. After, my team used to have it written down all the time in the rocket lab at our university, or my alma mater, but I don't remember anymore. So you guys want to do research on that to see how you should tie your or where your mounting point on the shock cord should be for each parachute.
Okay.
And usually, most teams would do, and most safety reviewers would require or like to see the drogue to be near the motor end, and then the
Okay.
main to be at the upper part of the rocket.
Okay.
So reverse
could
of
do
what
it-
we've outlined.
Exactly, but you guys could do it any way you want. Up to you guys.
Is there a benefit to either one? From what I looked online, there was like no exact answer of which one was better for the rocket.
I usually prefer the drogue at the aft end of the rocket because when you first separate, the motors, usually the tail end is the more heavier side, so make sure to pop off, and then the drag will really force the parachute out that way.
Gotcha.
Okay.
And then when you're falling under drogue, usually the upper section is the lightest part of the rocket. So when you shear that off going at a slower momentum, it'll just easily catch in the wind as well to open up the main that way too.
Okay.
But
Okay.
really, I haven't seen much different benefits of it. I've never seen someone deploy a main on the upper section of a rocket before, so it'll be interesting to see.
Okay. We will look into that. We can try to redo the simulation and see if it makes a big difference simulation wise. And then
Yeah.
I'll try to double check the weight. Because our nose cone's fairly heavy, but I also don't
Okay.
know like if the empty grain weight versus full grain, it might be full grain is heavier, but I don't know how much the weight changes once the burnout is done. I'll look into that.
Mm-hmm. So your main, or sorry, your drogue
drogue
will
would be from the nose
ejected
cone.
from the nose cone. Okay.
So that's the current design, yeah.
Is your nose cone going to contain anything like a payload or avionics or nothing?
We have a dead weight, or like what they call it, like a boilerplate type payload in the nose cone.
Yeah, I can,
Okay.
I can talk about the payload if you'd like.
But
I
that's
won't
it.
get
There's,
to that the payload section.
Okay, gotcha.
yeah, there's otherwise there's no nothing else in the nose cone.
Okay, so just empty weight, no electronics, no nothing. Okay. So, can I see the inside of the nose cone?
Taylor, could you help me out here?
Yeah, do you want to unscrew it? Or
No, just,
From the bottom end.
should I hold the phone?
yeah,
So you guys, do you have a what's it called? The U-bolt, how is it attached to the nose cone and from the inside?
This is attached to a bulkhead, which is the U-bolt epoxy to it.
Epoxied?
Mhm.
How much epoxy did you use?
We did, I don't think we measured the exact quantity. Ashna or Owen, were either of you there when Owen, did you epoxy this one? Or was it Vaco?
It might have been Vaco. It was just, I think, a standard amount of just like doing one layer, maybe going over one more time, but I think it was just like a standard amount like that.
I would advise, because a lot of the safety viewers, because from my perspective, it looks like there's really a small beading of epoxy. I would advise you guys to possibly add more, like a thicker bead of epoxy around the outer diameter of the bulkhead. Just to give it some extra safety comfort.
Yeah.
Of it
Sure.
possibly just being torn away from the force it to the main opening and causing it to have a sudden stop in acceleration. Or you guys could also decide to screw nails into the bulkhead as well as a safety barrier that way too.
The bulkhead's
Up to
pretty
you
thin.
guys.
So this is about how thin it is. I
Oh,
think
so
next
that's-
year we want thicker ones so we can do the screwing method, either
Mhm.
instead of epoxy or in addition. But the nice thing is we can remove, so this is like, this coupler is screwed in to the nose cone, so we can access what we put in as our dead weight. So
Okay.
this is epoxy to the coupler, so we can take the coupler out, add more epoxy and be sure of it on both sides of the bulkhead.
Mhm.
So I think there's epoxy in both ends, but I'll double check, we can take it out and check later.
Okay.
Yeah, I would
Um,
say check later, cause we don't wanna make a mess,
Exactly.
and it takes
If you
time
guys
to
could
set up.
definitely do that before you guys come to Las Cruces for competition. The safety reviewers for the in-person safety check will really appreciate that as just a
Okay.
safety barrier to make sure that it won't pop off.
Yeah, and honestly, I'm taking some notes for myself, I'll add a note also to just go through every connection point where there's significant force and double check epoxy.
Okay. And then let's go to the body tubes, all the body tubes you guys have on this rocket.
Alright. So that's the upper body tube,
Okay, the upper
and
body
then the
tube.
lower one is with the fins.
Okay,
And then the couplers, you understand the coupler, that's the connecting point between the two of them.
so the coupler is blue tube, correct?
Yes, and it's not fiberglass, I forget what the material is.
It's just called Blue Tube, I think.
Oh, okay,
It is
Yeah.
called blue tube, yeah.
convenient.
Um, are there any significant slots or holes in the body tube of the?
Yes.
Do you guys plan to exteriorly mount like cameras on the rocket? Or
We wanted
anything?
to, but we were worried about the aerodynamics of it and just messing too much with the outside of stuff we weren't as comfortable with. But the most significant thing we did custom was the slots that the fins are in, because these are through, they're actually touching the inner tube that holds the motor.
And epoxy. too.
Yes.
Yeah, they're
Through the
epoxy.
wall mounting.
Yeah, so
Yeah.
these were custom made slots, because last year we had a slotted tube and this year the manufacturer was not selling them, so we had to make it ourselves.
Okay.
So this, it's like, that's the biggest point of both pride, stress, and potential error. There's a lot of epoxy, and actually I'm gonna go back maybe tomorrow or in the next few days to add a stronger fillet on the fins. And sand everything down and then maybe do another layer just to be extra sure, because that was like the
Mhm.
most custom part of this. And it's the biggest room for error, even though they look straight, we're dealing with high speeds and we wanna be careful with it. But the team did a really
Yeah.
good job in putting the slots in.
So, quick question. What are the lengths of each body tube and the thicknesses of them?
The
this
lower
one's-
one is 48 inches. Thickness, I believe, is an eighth of an inch, but I can double check the numbers if you give me a minute.
Okay.
Do you have the report in front of you, Ashna, for the lengths?
I don't know where it is in the report. I can pull it up in my own notes once I find it.
Okay, that'd be
Yeah.
great. Yeah, getting that.
And do you know the length of the Ford their body tube?
I think it's 20.
Okay, I have the
Measured
dimension.
it at some point.
Ashna has the dimensions.
Yeah.
First one.
Okay, so okay. Actually, this seems wrong.
All right, let me pull
Oh.
up.
Our upper body tube is 30 inches long. Our okay, it's 0.216 centimeters thick. I'm not sure what that is in inches.
Let's look.
So about like 0.08 inches.
That is pretty small.
About.
I guess when we manufacture our own, they will probably be thicker.
Exactly.
I mean, these are machine made and,
Mhm.
factory done. I think buying a kit was a good idea for us to get started. It's made the whole process seem a lot less scary now that we know that it's a bunch of tubes.
Definitely.
But getting started, especially last year, we were like, we don't know where to begin. Yeah,
Okay.
yeah,
Um,
getting the numbers to confirm.
So I would definitely say try to get at least an eighth of an inch thickness. Because you
Okay.
guys are barely just above a 1/16 of an inch. Was the Wildman Mad Dog 6 qualified for a level 3 motor?
I think so. We chose this, in fact, from my recollection, I can check the website, it was under like a level 3 category that he was advertising his different kits under.
Okay.
And rocketry. Kits. Is it Wildman? This website is hard to use. Okay, 6-inch.
Was it specifically a Wildman kit or was it like an Aerotech kit?
Let me search it because I remember the name was Mad Dog 6.
It's under Mad Cow Rocketry.
Okay. I see it, yeah. So
It's perfect for level 2 or 3 on the website.
yeah. So it was suggested under level 2 or 3. I guess 3 is pushing it a bit, but based on the diameter and the different, like the inner tube that we were given for motors, because we were new to it, how we chose the motor was kind of based on making an open rocket of this rocket and seeing what fit inside the inner motor mount tube. And it all seemed to kind of really fit with level 3 motors. You could have gotten a smaller tube and made bigger centering rings for a smaller motor. And I know
Mhm.
people go to Spaceport with non-level 3 motors.
Yes.
But we chose to go with a level 3 motor.
Okay.
Yeah.
Uh, I'm trying to find it myself. I still can't find it. I'll find it later. Quick question about the motor then. Are you guys using a 4 grain, 5 grain, 6 grain,
4 grain.
4 grain? 75 millimeter or 98 millimeter?
98.
98?
Mm-hmm.
And then what's the motor that you guys are using?
An M3400 from CTI. Dubbed
Okay.
White Thunder. Presumably because I think it's got a white like white fire out of the back. Not really sure.
Yes.
Yeah.
So you guys have an initial thrust of 3,900 or sorry, 3,492.3 newtons.
That sounds right. And it should be about for burning for about 3 seconds, like 2.92, I think.
Yes. Okay. Let me see the back end of your aft section where
Okay.
your fin can will be and your motor can.
Yeah, and I just got a notification, even though I'm on my university account, that the meeting will end in 10 minutes. So I'm gonna, while Zeno shows that, I'm gonna get another link ready so we can swap to that
Okay.
quickly. Okay. So Zeno, you wanna show that?
Yeah, I might need help just getting it on the side, I think.
Ah. You're gonna turn this?
Yeah.
You go around.
You go around?
Yeah.
I'll grab one of the fins.
Yeah. So in between the outer tube and the motor mount tube are 3 centering rings. We've got one towards the bottom, one at the top, and then one right at the top of the fins.
Okay. How thick are these centering rings?
They're about as thick as our bulkheads. Ashna, do you have the exact number on hand?
I do not. I can look it up.
Okay, I would heavily suggest, because you only have 3 centering rings that are only millimeters thick, like your bulkheads. At the aft end, like the bottom end of where the retainer ring is,
Yep.
make a thick puddle of epoxy.
Okay.
That pretty much goes to the tip of the exterior ring
Okay.
there. And then another thick puddle on the other side, on top of the very top centering ring, to make sure that your motor will not blow out and go up through your whole rocket.
Okay. We will do that.
So tape up the motor, or tape up the hole where your motor will go in, and make sure you don't get any epoxy inside that inner tube, or your motor will not slide in.
Yeah, another big challenge we ran into this year was when we initially were epoxying, centering the inner tube, we left too many things assembled that shouldn't have been assembled. And we learned how to unepoxy epoxy, but it's a very painful process and we won't do it again.
Oh, it definitely is.
Yeah, this got stuck inside the motor mount tube. So we're gonna be very careful.
My last year competing as a student, during our test flight, our main parachute didn't open, but caused enough drag to slow it down still, where we lost a fin. We had to figure out how to get the remaining broken end of the fin out of the motor tube, or fin can, and epoxy a new one on. So I understand the difficulty of removing epoxy when it's already hardened.
A lot of acetone and a lot of paint thinner, and a lot of the heat gun, just holding it, trying to melt it.
We used a Dremel. I just dremeled it all
Yeah.
away.
Yeah.
We didn't want to like mess up the metal, because that component, like buying the new casing or any of the new retainer would have taken too long before
yeah.
our budget ran out for the year, because the school like ended us being allowed to use money on May 1st. So we were like, we need this to be, and it would take like a few weeks. Yeah. But it's out. It's all good. This goes in nice and smooth. So we'll very carefully add a lot of epoxy.
And then, can I see the fillets so far of the fins to the body
Yes.
body tube?
So we've done one side, and this needs to be touched up.
Yeah, this isn't complete yet.
Well, actually, we've done one fin. The other side, the other fins have less of a fillet, so you can see how it's a lot thicker here.
Yeah.
This one, here, I can turn it a little. So this fin has a thick layer that's like seeped down, so we know that it's really strongly epoxied all the way through. And basically, we let the epoxy stay fairly liquid when we start so that it drips down, and then as it hardens in our container, we just add more of the putty so that it can be more malleable. And I think I'm just gonna redo that either tomorrow or Friday, come back in. Do as much fillet as possible, and then I don't know if I wanna sand down the parts that have kind of gotten on the body of it. and then refill it, or sand it down first and then fill it completely and see what happens. I don't know what order I'm gonna do that in yet, but that'll be a tomorrow and Friday job.
Okay. I would highly suggest building up that fillets on each
Mhm.
side of the fins. Since you gotta have very thin, um, excuse me, um,
The fin itself is
fillets
not,
now. Most teams would also, like when they're doing fillets, like for their fins, add milled fiber, so like pretty much fiberglass dust or carbon fiber dust to make it like a very snotty, sticky mixture, so it wouldn't be so runny and give more support that way as well.
okay,
Most likely it's
Which-
too late
yeah.
for you guys to buy it through your university. So maybe
Can we
next year
make
that
it?
could be a good idea to do as well.
Could we, in theory, because there's a machine shop that I think if it's not open in the next few days, it will be open soon, and I have a friend who works there at the shop on campus. Is it possible to use sawdust or cannibalize some of the old fiberglass we have to make some sort of dust composite?
You probably could. I would suggest doing like test strips before you put it on your rocket to make sure it'll cure properly.
With
I've never truly
okay,
done sawdust like that before,
okay.
but definitely test it before you do it.
Mhm.
If not, try to have each fillet kind of like at a perpendicular to the surface to have
Okay.
this split perfectly in a like a V form, and have like tape up the edges of the aft leading edge and the aft edge of the fin, so it won't run down or past the fin as well. Make sure
Gotcha.
it
So
pulls up.
essentially making some sort of stance that it stays kind of like, well, it's bouncing on again, but kind of like this so that it's flat here.
Correct.
Okay, I can do that.
Most teams usually do a tip-to-tip layer 2 to make sure it's one cohesive surface instead of
Okay.
having just the fillets as well. Usually people don't do that on a kit because they don't buy raw fiber or carbon fiber to do the tip-to-tip layer. Um, most safety reviewers would always like to see this tip-to-tip done. One thing I would like Xeno to do with the fins like that on the table, push down as heavy as he can go on those fins right now.
All right,
Oh, man.
Kayla, could you hold the phone for me?
Teams hate this test
Oh, this is
because they can easily
scary.
snap their fins off. It's flexing a little bit.
Yeah.
Wrong
You
the whole
want to
table.
make those fins as stiff as possible.
All right.
So that to me the little bit of flexing the fins is not bad. I've
Okay,
seen a lot worse. For
Good.
this rocket for sure, definitely add thicker fillets
okay,
for the fins.
Okay.
okay.
And the next year when you're gonna start doing your own layups of tube or fins, make sure you buy extra material for a tip-to-tip layer, which will go pretty much around one side of the entire fin plate, from like the left side of the top fin to the right side of the fin on the left on the screen.
Okay. And tip to tip is the whole fin, not the rocket, because we need the rocket to.
Yeah, just the
Okay.
fins from
Yeah.
the aft edge of the fin to the top edge of the fin.
Okay.
Maybe a little bit past the top edge, just to make sure it overlaps properly on how the
Yeah.
fiber will lay down on the curve.
And I guess I could do that with epoxy. Like once I do the thicker fillets, do it with a thicker layer of epoxy. I worry about it being lumpy though.
I won't do the tip to tip with epoxy only because it does get lumpy.
Okay.
You would need to have the fiber there to help it make sure it's gonna be smooth and sand it down
Okay.
later.
So if I can find a way to add fiber to the epoxy, that might be a better idea.
Okay, let's do it.
Okay, so Kayla, what was your question that you had before we got cut off?
I was talking about doing a tip-to-tip cover with epoxy mixed with some sort of fiber. Might maybe a good idea, or just add strong fillets and hope it's enough.
I would just say do the strong fillets, definitely make them beefier and bigger.
Okay,
I would only recommend a tip to tip if you actually had raw fiber to actually layer on top of the
Like a sheet.
fins to make it a one complete transition from the body tube to the fins.
Mhm.
But next year, definitely when you guys start manufacturing your own tubes and fins, look into the tip to tip layer. There's a lot of videos out on YouTube to like how to properly do a tip to tip layer for fins.
Okay. Gotcha, thank you.
No problem. Also on rocket markings for your team, please please go and look at DTAG 8.7 and Appendix F in the DTAG to make sure
Okay.
you guys have your team number and frequency on the rocket.
Okay. Yeah, we are, 'cause it's unpainted, so we're currently outlining what it's gonna look like.
Okay.
That's in like the main document, right?
Connor, what would you recommend
Uh,
for painting the rocket?
Some teams use spray paint, some teams get their rockets professionally painted. I know
Okay.
my team, we would go buy car paint and paint it outside of our rocket shop with pretty much hazmat suits.
Yeah.
Plan is to spray paint and like make stencils, and maybe do some freehand painting.
You could do that. I know the University of Akron last year had kids paint their rocket whatever they wanted during conference day. So they came with pretty much a bare blank white rocket
That's cool.
That's
just
cute.
like team numbers and their frequency on their rocket, and everything else that was just white. They had kids paint as they were walking by.
I love that.
But it's all up to you guys. You'll definitely see teams there with like really nice paint jobs, which makes you feel like, oh, makes us look like we're nothing.
It's like we're amateurs or something.
It's our first time.
I suggest do not paint your rocket black or sky blue. You want something to really out or not be blended into the sky. White, black, or white's fine, black is not.
What if
Because
we,
don't forget the New Mexico heat, black absorbs all the heat.
Yep.
what if
And
we
you don't
did
want anything.
reflective paint?
You could. We've never seen actually people do reflective paints. One year last year we did have a team paint their whole rocket black. We forced them to put aluminum tape on their body fin or body.
Yeah.
So they can at least see some reflection in the sky.
What if we just cover it with aluminum tape?
Speed tape rocket, I love that.
Okay.
But also just keep in mind the heat of the sun in New Mexico. Last year it was like in the high 90s, low 100s. This
Yep.
year they already are predicting 115 in the desert for June.
Yeah, we've got
The
jackets.
hottest it's ever been.
We've got a reflective like sun. I don't know what to call it because I'm not from somewhere that's getting super hot, but jackets that help block out the sun, I guess.
Oh, the UV shirts?
No,
They're
not
great for
quite that. I went to the company that used to make I used to row, and the company that used to make our jackets, Boathouse. I remember just always feeling cool. They're vented, even in 90-degree summer heat. And so I made Penn Rocketry Boathouse rowing jackets that worked great for me for years for not letting me burn in the summer.
We'll see.
The jacket is not the best idea in my opinion.
Jacket is a misnomer. It's very thin material.
Is it kind of like lycra kind of or like a polyester.
Very, very thin nylon, I think.
Okay.
I'm not sure what the actual material is, but it's very thin nylon.
That might work because usually you do want to wear at least a long sleeve to help protect from the sun.
Yeah,
But we'll
All
talk
right.
more about that after we go through the whole entire rocket.
yeah.
But yeah, definitely for the paint job, just make sure it won't also be too hot for all the electronics inside the rocket.
Yep.
So try to avoid black as much as possible.
All right. Yeah, we have some ideas. If you haven't noticed, we're a little silly with some things of our project. So Project Longshot and our rocket being named after a Honda Odyssey. So that's what H
That's
Odyssey
pretty funny.
stands for.
Oh, I saw that, yeah.
It's not Homer's Odyssey, it's Honda Odyssey. So I
Who
realized
owns the
H-
Honda Odyssey?
what?
Who owns the Honda Odyssey on the team?
So funny enough, nobody does. I actually forget how this came into being last year. It's funny though, because since then I've actually, I got a car since then, and that's the car we're using to drive the rocket, and it's a Civic. So it's a Honda, but it wasn't, H Odyssey came before me getting a Civic.
We just talked about how practical a minivan is, and we talked about the fact that somehow when like cars get stolen, they're often sold for parts for like missiles, and how a
Yep.
lot of car GPSs have a safety built in where if they go too fast, they shut off because you don't want to be used for a missile. So we joked that if we couldn't build a rocket, we could just take a Honda Odyssey and turn it into a rocket.
Oh, that's what it was.
Yeah.
I remember now.
And that's where it started.
I like it. I like it.
Thank you.
Yes.
So what's next?
Coupler. So we know it's blue tube,
Mhm.
and it was a thickness of 1/8 of an inch.
Yes.
How long was the coupler?
Oh,
It should be 9 inches.
9 inches.
Yeah.
Yeah, that's about right.
And what's the how thick is the switch band on the coupler?
It should be the same thickness as our body tubes, as far as I remember.
I
So
think,
like
do you mean this thickness?
Yes, that thickness, Kayla.
I don't have the exact
There it is.
number on hand, but we can measure it quickly. And it is 1¼ inches.
1 1/4. Okay.
Mhm.
That leaves you with 7 1/2 or 7 3/4 of an inch.
Mhm.
That will leave you with under 4 inches on each side of the coupler. Usually, we want the shoulder length to be no less than 1 body tube diameter, which would be
Okay.
technically 6 inches.
Gotcha.
You'll be definitely scrutinized without having that 1 cal coupler.
Okay.
Is it possible to buy a longer blue tube?
Potentially.
we might have some scrap that
Yeah.
'cause we actually cut it down a little bit. So we might be able to salvage some of that.
Well,
Okay.
this is the biggest piece of scrap we have. I don't know if it's a good idea though to epoxy it like on top. So I think
No.
it'd be better to just buy a new piece.
You can buy Bluetooth.
We should be able to.
Okay, and if you want to like make sure it's going to be DTAG 8.5.2.1, that will state that shoulder length of the coupler should be a minimum of 1 body tube diameter or 1 cal. So it should be a minimum of 6 inches on each side of the switch band.
Okay.
So
Noted.
if you're having a switch band of 1.25 inches, you want the whole coupler tube to be at least 13.25 inches long.
Okay.
And then make sure that will also fit in your rocket design on Open Rocket.
Yeah.
If it doesn't, you can always just tell your safety reviewers in person. The first time building your rockets, as just a design flaw where we couldn't add any more length.
Yeah,
And are you also using shear pins to bolt that coupler in, or
We're
Um,
using steel bolts for body tube, so that'll be
Okay.
permanently affixed. And we're using 4 nylon shear bolts to affix it to the lower body tube where it'll separate.
there's also 444 shear pins?
Yep, it's exactly the same as the upper part.
so we'll look into testing that with increased amount as well.
Yes. What will be contained inside the coupler?
Our avionics.
Avionics, okay.
So Zeno's getting it right now. So we have this like kind of sandwich sled. And those threaded rods are gonna attach to the bulkheads that are on either side of the coupler. Or that will be on either
Okay.
side.
How will your electronics be mounted inside the coupler?
So
Um,
yeah,
You guys hear me?
yep,
Yeah, we can hear you.
Yes.
Yeah, sorry, I'm at the airport right now. I was supposed to be on the plane right now, but it got delayed by 3 hours.
Ooh,
Yeah, it's a
Hey,
it's a whole
Matt, are you
thing.
at LaGuardia right now?
What?
I bet you're flying American.
No,
it had issues.
it's
All right, so yeah, how are they gonna
I
be,
forget the name of it, but yeah, so all of the boards are there's metal 440 bolts that go through mounting holes in the board all the way through the acrylic, and there's 2 nuts on the other side. And then there's a little bit of foam underneath each of the boards to help with vibrations during the launch.
Okay.
Yeah.
And then
Okay.
all the batteries are so there's Velcro underneath the battery attaching it to the acrylic, and then there's a zip tie over top of it to
Awesome.
really keep it on there.
you wanna get
Okay.
the bulkheads that have.
I like
Yeah.
the zip tie idea because most people just go with Velcro, and we will always tell them to drill holes to add zip ties to it as well.
Great.
Yes.
There are the holes in the coupler that we're lining up right now.
This, it'll be screwed in more properly, but you're just seeing how it fits. That this is,
Yes.
we've custom, Owen made custom containers for black powder, so this is one side and there's gonna be another bulkhead on the other side with similar holes.
Okay.
Mhm.
And then what are your altimeters?
We've got a telemega.
So the big board on one side is a telemega, and that has an onboard altimeter as well as GPS and some other stuff. On the other side, there's also a telemini, I think it's called, which is just an altimeter.
Okay. Do you guys have a backup GPS just in case?
Yes, that's next to the telemini on the other side.
It's featherweight GPS.
Okay, featherweight.
And
I
it's
use
an
it all
easy,
the
it's an
time.
easy mini. We got
Ex-
easy
okay.
mini and featherweight for backup, yeah. Have you used either of these boards before?
I've used the telemega. I usually use the RRC3s from I think it's Missile Works. Who
Okay,
puts those out? Puts those out. But telemegas are pretty easy to program as well. I've never used it Easy Mini, but a lot of teams do use Easy Minis. When you go after launch and you could recover your rocket safely. When you go to post-flight data recovery,
Mhm.
make sure you bring any cable that comes for the telemega or Easy Mini, because Asteroid does not provide those.
Okay,
And if you can't get your data recovered the same day, you'll lose points.
okay,
Okay. I think the
Yeah.
cable for all 3 of the boards is micro USB.
yeah, it looks like it, I'm checking them out right now, they all. I don't see the one on the featherweight, but it could be because of the foam.
The featherweight
Well, the
might not have
featherweight
one
won't have your
'cause it
altimeter
goes to
data
your
because it's just a
phone.
GPS.
Oh, you're right, so yeah, the two boards, Easy Mini and telemega both have the micro USB. Or whatever it's called, micro SD. I forget the names. It's the trapezoid one.
Mhm. And then can I see the bolts on the sled, your electronic sled?
Yeah.
Well, I should say the bolts that are connecting the acrylic plates together.
Sure.
You go on
those
six.
are
632s, I believe. And there's T-slot joints holding them together.
For every bolt on your sled, I recommend, or holding all the electronics together or onto the sled and the acrylic together, hot glue them.
Okay.
Because they will rattle loose in flight.
What about Loctite
You say epoxy?
or Loctite?
You can use Loctite as well.
Okay.
Don't go with the red Loctite because that is a forever mount.
Yeah.
My team their first year in 2018 learned the hard way.
No, you want to reuse
And
the
at
boards if
work,
they survive.
yeah. And I know at work now we always just joke around. Don't forget the red Loctite, everybody.
Yeah.
Can we
Yeah.
screw and unscrew everything over and over again?
Yeah, I had to use
So
red
make sure at
Loctite.
least use the blue Loctite or put thing is just hot glue to make sure it just doesn't unravel itself.
Okay,
And you have loose hardware flying in your rocket.
sounds fun.
Sounds like a bad idea. Sounds like a bad day.
Yeah. 1 second. That's good. That's good. Let's go. Are the batteries within the D tag of not being a LiPo?
All three of the batteries in the Av Bay are LiPos. I think they're like 3.7 volts, 500 milliamp.
Okay, give me 1 second to pull up the D tag. Control.
Oh, sorry, 400 milliamp.
This is random, but Zeno, could you mute one of your devices? Because I'm getting a lot of echo on my end.
My phone. I don't have audio on my phone. It's not connected. And I'm muted on my phone too.
Oh,
The
weird.
only
Okay.
device it's just my computer and Connor, but I don't have feedback.
It could have
Okay.
been when I was just moving the computer, because it's sitting on top of this box and I was looking for something in the box.
Okay. Maybe.
Are you still getting?
So, Matthew, was it you talking about them being a LiPo or a lithium ion?
They're Li-ion.
The lithium ion, correct? You said?
Yeah, Matthew,
Yeah.
I'm pretty sure these are Li, they're not
Okay.
LiPo.
Yeah, they are
let's-
lithium ion.
Okay.
It should say it on the battery. If you guys can look at the casing.
They're slightly
It
covered.
doesn't say on the top side of the battery.
Trying to see if we have any of the extras in the box behind us, but I don't see any yet. Go around it.
Yeah, I don't.
And is that in a so if you read in DTAG 6.20.6, lithium ions in a rectangular form factor and or with plastic casings are prohibited.
I thought they were lithium ion, Matt.
Wait, is it LiPo or lithium that is prohibited?
It's lithium ion.
Oh,
The only lithium ion are permitted will be in a circular or cylindrical metallic casing.
what is,
A
what,
circular.
Matt, I think I wasn't I the one that originally bought the batteries last year? Back when I- electrical.
So I don't know about for the telemega and the backup altimeter, but for the GPS, that battery is the battery that came with it, and I believe it's permanently attached to the featherweight GPS. So I think
I'm
those are
I'm like 99% sure these are LiPo batteries, but we can look at purchasing history. We can look at serial numbers and check.
Yeah, we have all the orders
Yeah.
from this year. Matt, do you remember if you purchased these this year or last year? So I can look it up right now. We need to switch it.
Batteries and boards, I think were purchased last year.
Yeah.
That'll be a little, let me look it up. It'll take me a few
So
minutes.
I did look up Telemega. Telemega does use a 3.7 volt LiPo, but it is recommended by the manufacturer to use that type of battery to power the device, which is perfectly fine. If you read DTAG 6.20.1, unless installed in the power device by the manufacturer, or we recommend it and supplied by the manufacturer. What you most
So-
likely bought them with the Telemega.
I
Easy money.
believe
They are
those I
LiPo.
believe
Yeah,
those batteries
they're-
came with
they're
the
LiPo.
boards too.
Okay, show them the screen.
I don't think we bought separate batteries.
So I just checked our purchasing sheet from last year and this is what we bought and they are LiPo batteries, 400 mega amps or milliamps. I can't tell what it's all capital here. From Apogee.
Okay.
Yeah. Yeah, I could have sworn
So
those were
just-
LiPos.
When they question the LiPo battery, just mention that you bought them with the Telemega.
Okay.
Yep.
Sounds good.
And they are, so what section of the DTAG is this again?
If you go on soundingrocket.org,
It's the
And then
design
go
test
under-
and evaluation, right?
yes. Oh,
Okay.
the file should say 2023 SA Cup DTAG version 2.2.9.
On it. What section, what's the section to look at to confirm for batteries?
6.20.
Awesome. Okay.
And then 6.20.1 does states if it is recommended by and supplied by the manufacturer or powered already installed by the manufacturer, it's allowed.
Yeah. So yeah, we bought these for the Telemega, and what's interesting is the link that on Apogee calls them LiPo, but looking at the picture on Apogee says L-ion. So
I mean,
I don't
LiPo,
know.
like lithium ion batteries in this form factor aren't too common. Like,
It just says that if these are lithium ion in rectangular, that's prohibited, but also LiPo batteries are not permitted either.
we'll search serial numbers.
So if we
I know last year we had a lot of batteries catch fire from rockets that did not come down safely. That's why there's been a lot of change with the batteries contained in the rocket this year for competition.
Gotcha.
That's why there's also been a lot of extra safety measures put in place for this year. After we had a rocket come down ballistically
Mhm.
about 20 feet away from a team.
Yikes,
At
that's
base
really
camp.
bad. That's really
Yeah.
bad. Oh, man.
So
Well,
all
I'm
these
glad-
safety measures in the DTAG are for a reason.
Yeah.
We're not trying to make a team suffer more by having all these safety requirements in here.
Mhm.
It's for the safety of everyone at a competition as well.
So if these batteries are bad, and even though we can try to reason with the final safety review, I still want us to be safe. These, if we had them in circular form, it would be 100% okay.
Correct. If they are lithium ion, if you have them in a circular format, they will be perfectly fine.
Okay, I'll look into that.
Okay, yeah. We'll make sure these are lithium polymer to begin with.
Well, no, lithium
Mhm.
polymer is all bad, and lithium
Oh.
ion is only allowed if it's cylindrical.
Oh, I misunderstood you.
Yeah,
Okay,
so the battery is very specific.
I gotcha.
Definitely next year for competition. Beginning of the school year, the whole entire like sub-team leads and leadership of the team need to sit down
Mhm.
together and go through the DTAG to make sure everything is being followed correctly.
Yeah. I think we'll even do that this summer. Our plan is
Yeah.
as soon as Spaceport is over to redesign and get ready for next year. So.
Yep.
Okay. Do you know when the next one gets released? Or we can use the current one as reference and double check changes.
Yeah, you can always use this one as a reference, but Usually we will always update the D tag until about the first report.
Okay,
Because Astro's not the only one who gets to say what's going to be in the D tag. Spaceport America or the New Mexico Spaceport Authority also gets to say what needs to change for safety since we're using their property and their land.
okay,
So, like you've
Yeah.
noticed on the Sounding Rocket website, it does say the D tag was updated last on 10/24 of last year. And most teams were already doing report 1 by then.
yeah. So we'll use this as reference for this year, and our goal is to have the rocket design finished at least halfway, at most halfway through the first semester of next year, so that we can start constructing and be done much more comfortably during the spring semester. We're finishing now and the semester's over, so we kind of want that to not happen, so we have more time for things to go wrong, I guess.
Exactly.
So yeah, we learned a lot this year. Yeah.
That's good. And how I see it, the more you do rocketry, the more you learn to be better.
Yeah, that's the goal.
Okay, so let's go to recovery.
Okay.
Shock cords, you guys mentioned it is 30 feet inch or 30 feet for each shock cord. Nylon tubular with Kevlar fire protection closest to the ejection charges, which is good. What size, color is your main parachute?
Size of the main is 10 feet, 120 inches. Color is red, whatever Zeno's showing. Looks like red.
It's like a
Is
reddish
it red
orange.
and white?
It's I can't quite tell.
I see white here.
Yeah, it's red and white.
Okay.
I don't know, it looks more.
Since it's a
orange.
brand new parachute, before you pack it into your rocket, I highly suggest baby powdering both sides to make sure it won't get stuck together and won't open up. The baby powder will make sure there's no moisture to keep the nylon ripstop parachutes from sticking together.
Okay.
Go by baby powder.
I don't have that home.
What type of parachute did you guys buy for your main?
The main parachute is it was through Rocket Man. It was just their high performance parachutes. Coefficient of drag 2.2.
Okay. What will the descent rate under the main be?
Under the main, let me look up real quick. Main descent rate, what we calculated so far is around 16 feet per second.
Okay. That was good. That meets the D tag. And now what is the drogue size and color?
Drogue should be a 24-inch diameter. That color looks orange or
It's like from our perspective, this one looks like a yellowish orange, and that one looks like
It's, yeah.
this looks like a street cone type orange, but it's looking red on the camera, so it's kind of looks like a tomato.
Okay.
Tomato and tangerine. I don't know.
There is somewhere in the D tag that does mention that the two parachutes should be conflicting colors.
Yeah.
Yeah.
If the main is more orange than it looks like on the camera, that's closer to the drogue.
It's
They may
a
not
pretty
like that.
drastic difference in
Okay.
person.
Like calling them both orange, yes, technically, but they don't look the same.
Yeah, there's the comparison.
Yeah.
It's pretty drastic.
So just make sure for next year to have maybe more contrasting colors, like a
Okay.
lime green drogue and maybe like the same main. I know it's cheaper to buy a drogue than a main parachute.
Yeah. Can you paste the link that I just sent you in the chat? For the new Zoom on this?
Yeah.
Do you have WhatsApp on your computer?
I don't.
I'll email it to you. Okay.
Yeah, so we just got the 10-minute warning again.
But this time we're gonna bounce to my computer, so I'm sending the link here and we'll be ready to bounce immediately.
It'll be fast.
Yeah.
We're learning.
And then what will be the descent rate for the drogue?
Does somebody have the open rocket specs?
The descent rate for the drogue is around 80 feet per second.
Okay.
Was it
If I
RC?
remember correctly, he had to be under 100 feet per second.
Something around there, yeah.
Let me double check that. Initial 6.3.
There it is.
So actually the descent rate under drogue should be between 20 and 50 meters per second. What should be 65 to 165 feet per second. So you guys are in the good range for that. Main should be less than 36 feet per second, which you guys are doing 16. You guys are good to go on that.
Awesome.
Your drogue chute should technically deploy at apogee,
Mm-hmm.
which should be
Mhm.
10,000 feet, correct?
Yep.
That's the target. Based on simulations, it's slightly higher. We don't know if we should release at 10,000 or let it actually just reach its apogee and release there.
Release its apogee, because if you're still going up in momentum, the rocket will probably not want to separate properly. So it
Okay,
might get
so we'll
stuck.
release at apogee.
Yeah.
Yeah,
What
it'll
is your
be,
predicted altitude right now?
I think it was 11,000.
I think
And
11,020.
yeah,
Well, that, oh, and I couldn't hear you.
11,020.
200? Okay. And then at what altitude will your drug or main deploy?
Main's gonna be around 650.
650 feet, okay. And that's fine, cause Casby below 1,500 feet. Awesome. And you're also using right now scheduled for 440 shear pins, but might go up to 6, correct?
Yeah.
correct.
Yeah.
Okay. You're using black powder.
Mhm.
Is the Are you guys buying black powder pre-made charges or making the charges yourself?
We make them ourselves.
Okay.
Yeah. I actually have, do you have the bag of the charge capsules?
The bag, I have here's the
Do
bases.
you have, there's a bag of all the other capsules that I made.
Yeah.
Owen designed custom capsules that are gonna slot in. So we can like kind of make sure, pre-weigh it outside, make sure it's all good.
Here, do you want to hold it? Well, I'll put
Right
the,
below, right the back, great things.
I know, we just had that on.
And show you what they look like. They're
Okay.
3D printed, very clever.
Yeah.
I don't know where the bag went. We put the bag somewhere, find it when we clean up, I guess. Yeah.
You at this point, you guys are supposed to show me a video of your deployment tests and the
Oh.
Blackwell charge containers. When you do your ground testing this weekend,
Mhm.
please video how you guys load the charges in and the deployment of the rocket. And you guys could just email that to me as well.
Sure,
I
and
could make sure.
Owen, we have videos of the earlier tests. The reason we're doing another ground test this weekend is because the earlier tests were done with PVC mimicking the rocket to make sure
Okay.
that it's float apart. So we have video of that, but we haven't tried it yet with the actual rocket structure. So we want to do a full ground test to be sure that all of our charges are properly weighed.
Okay, yeah, the video I'm looking for will have to use the entire rocket that you're using for flight.
Okay, we'll send that to you.
And then I know you guys are using shock cord protectors. Are you guys using any parachute bags to protect the parachute from the explosive charges.
We're using Nomex blankets right now.
Nomex, okay.
And we're also using at least from testing, we figured we're actually putting like a little leather cap right on top of like where the charge comes right out. Because what we found is during testing is like if you just have the Nomex blanket, it gets destroyed very fast. So
Yes.
you put a leather cap there and it just takes like 95% of the charge. And then the Nomex blanket just for fireproof safety as well.
Okay. I know most teams also buy like loose insulation at like Home Depot. We call it dog barf in the rocketry industry. Also throw like a few hand scoops in there between the shock cords and parachute and the explosive charges. That also helps as a safety barrier too if you don't use the leather cap. I like to usually use a parachute bag for my main parachutes. It just makes sure the parachute doesn't get tangled in flight and keeps it all nice and pretty much compact in the airframe, and it will nicely slide out for deployments. But it's up to each team. You don't have to use a deployment bag.
Mhm.
So maybe next year, as you walk around the convention center this year, you'll see a lot of different ways you could do recovery, designing of your rockets. So
Yeah.
take time this year to talk to teams with different designs and actually pick their brains about why they chose like that fin shape compared to what you're using now, that different ways of recovery deployment charges and stuff like that.
Yeah.
Do you guys plan on using any swivel links, quick links, or hard points for your connectors?
Yes. So the current plan is we'll have so the end of the shock cord, they have the loops. But we're gonna use we're just gonna use some carabiners to connect those easy. Those are both rated at 25 kilonewtons. So those should be good enough for the rocket force, I think.
So wait right there, Owen. Astra says no to carabiners.
No carabiners? Okay, then I can get rid of those.
No carabiners, you will not be safe to launch until you get at least a quick link.
Okay.
Okay.
You can quickly buy those at Home Depot
Okay. What's the
or
difference
Lowe's.
between the quick link and the carabiner?
A quick link is rated a lot higher than a carabiner. Even like the rock climbing ones that you currently have on, they could break under the forces that you'll see on deployment.
Okay.
And then usually, it's not a requirement to use swivel links, but a lot of safety reviewers will kind of nag at you if you don't use them. They'll say you don't know if like the eye bolt on your if you're using the eye bolts on the other end of the upper section of the motor will unscrew itself as it's spinning coming down in flights. So then we'll just eventually pop off the eye bolt and just come down like a lawn dart. You might
Yeah.
want to just throw in a few quick or swivel links to make sure you allow it to spin without anything unscrewing
Yeah.
We have
right
we have
now,
on the
swivel.
shock cords at your attachment points.
we have
We got
swivel
swivel.
connecting the shock cord to the parachutes, not the shock cords to like U-bolts, but just shock cord to the parachutes right now.
I think it's just a safe option to also have a swivel link at each attachment points, just in case. Well, is the mains deploying from the aft end? What are the two attachment points for the main parachute? Are they both U-bolts?
Yes.
Yeah.
Did you guys lock tight?
Sorry.
For the U-bolts, did you guys lock tight the bolts connecting the
We've epoxied them.
epoxied? Okay, so they have a chemical bond that will unlikely unravel itself. Awesome.
Very unlikely. Yeah.
And then your vent holes on your couplers for your altimeters.
We haven't made the vent holes yet, to my understanding.
Okay.
that was kind of a last minute. We weren't sure exactly how we wanted to place them. We also were thinking about putting a vent hole in the nose cone, and we haven't done that quite yet either, because we aren't sure yet where exactly we want to place them.
We have one vent hole on the lower body tube. I don't know if that's related to what we're talking about. It should be right above the upper rail button, I believe.
Yeah, I see it over there. But yeah, that's not connected to where the altimeter is though.
Gotcha.
Yeah.
You want your vent holes to be closest to the altimeters for a perfect reading,
Okay.
and you will want at least 3 or 2 to 3 properly sized vent holes in at least your switch band on your coupler.
Okay. So we'll add that once we determine if we can get a longer blue tube or not.
Correct. If you can't get a longer blue tube, still add the vent holes in the switch band.
Okay,
Okay, you want those vent holes for the altimeters.
gotcha.
If you have no electronics in the nose cone, you shouldn't need a vent hole there,
Okay,
only where the altimeters are located.
okay, yeah. Good to know. We were worried about pressure, but I guess the pressure really just involves if it's gonna mess with electronics.
Correct. Because if you don't have enough pressure, or if you don't have the vent holes properly sized to make sure the pressure inside the ejection bay isn't the same outside, you won't get the proper ejection charges at the altitude until it reaches its pressurized altitude.
Okay. So would a
Since the
drill be
altimeters
fine?
are pressurized, or pressure sensors, pretty
Yeah.
much.
So we should make it's okay to make these vent holes with a drill?
Oh yeah, that's how most teams usually make their vent
Okay.
holes. If I remember correctly, for a 6-inch body tube, you want, I think, 5/16.
Okay,
But double check that math or find a other survey or other reports about how to properly size a vent hole for your altimeters.
okay.
What type of rail buttons are you guys using?
They are airfoil style.
Airfoil? Are they 1515?
Ashna, do you know?
Not off the top of my head, but the info sheet should be in the green bin. There's a white UPS box, and the Ziploc and info sheet should be in there.
There is no UPS box in the green bin. I know what box you're talking about. I don't know where it is. Let me check the
I
red bin.
think if I had to spit out a number, I would say 332. That's what I remember for the screw size.
That might be the screw to screw it in.
Actually.
Yeah, I'm looking, all I see is IFS. Or YFS.
I can check on the sheet when we ordered it. I'm not sure where this box went, Ashna. I'm gonna find
Okay.
it.
Let's see. Yeah, so the screw is an 832 3/4 inch socket flat.
But I need to know if your rail buttons are meant for a 1515 rail.
Let me check.
Because they do make 1010, 1515, or the metric.
It says it fits 1010. Is
You
that
will need the 1515 size.
okay?
That is stated in the D tag section 8.6.1.
Okay. We can order that.
And we do not accept 3D printed rail buttons.
Okay.
And currently, where are your rail button placements on your rocket?
We've got one right at the very base, the aft end of the rocket. And then one
Yep.
all the way at the upper-ish end of the lower body tube.
Okay. Is your coupler sitting directly below the upper rail button? 'Cause I saw a screw hole below the rail button.
That was the vent hole that was made for the lower body.
Yeah, that's the vent hole.
Okay.
Yeah,
Yeah, and this is how the coupler.
I guess if the coupler is longer, it might overlap, but it shouldn't matter. We can always add another vent hole.
Yeah.
Can I go definitely say usually you don't want your upper rail button that high
Okay,
on the
you could lower
Um,
it.
usually I would do about double the length of the space between your CP and CG locations.
Okay,
So let me see the longer side of the aft tube. I would go probably 6 inches of, or let me see the end of the aft side as well.
Yeah.
you wanna get it all in one shot?
Yeah.
Yeah, I know it's hard.
Yeah, I mean, we could turn it.
Is that a fine format for you, Connor?
Yes, that works.
Okay.
I would say go halfway between the leading edge of the fin to the top of the body tube. So about like a little bit lower than half.
Okay.
Like right there.
Okay.
Yeah,
Yeah.
We can do that, because we'll need new buttons anyway,
exactly.
will it be okay that then that hole is just open at the top?
It'll be fine. You might lose pressurization to deploy. So we could easily do right before launch, slap some aluminum tape to cover up the hole.
Okay, tape is good enough?
Yeah,
Okay.
I use aluminum tape all the time.
Awesome.
What type of switches are you guys using?
Is Matthew still on here?
Matt?
I don't know the exact name.
Yes, I'm here.
All right,
This is for the launch system, right?
Correct. To arm all the electronics.
you wanna show?
Yeah, so we have a key switch, and we also have a switch with a flip cover, and an LED indicator. It's on Zeno's screen right now.
Yeah, once you key it in, then this switch becomes active. Flipping that, there'll be a red indicator LED indicating that it's active. This non-toggleable spring-loaded switch here is dual.
I'm getting the key out right now. This is the other end of it, and this is like what's gonna be next to the rocket, and the key is inside, so we don't lose it, but I have to unscrew it now.
We were just
Okay,
demoing.
so
You showed the video.
Yeah.
Mm-hmm.
the terrain of New Mexico, usually where we're sitting at main base is going to be lower in elevation than where the rocket pads are.
Okay,
My knowledge of wireless transmitting lower than where everything's going to be is bad.
Is it still line of sight? I thought we were supplied a tower that we can throw these things on, or at least some sort of elevated platform, right?
here's the key.
It did say in some spaceport document that we would have line of sight to the launch pad. I forget which document that was in.
We tested this system. I forgot that we used a rangefinder that maxed out at something like 1.5 miles, and it was still working up until then, and probably up till 2 miles, even over some hills in the Pennsylvania backcountry.
Okay, 'cause I know when I was at Spaceport America in January to like get stuff situated out then, from the launch pads to where the range safety person sits on the Connex box, you couldn't see the top of the Connex box at all. And they were going to have towers to make sure that they could communicate back and forth from each pad site to the Connex box, or the LSOC we call it.
Mm-hmm.
Yeah.
You would have to, with your own launch box, you would need to probably come out Saturday or Sunday before competition
Oh.
to make sure you work with Esra to get that situated in place.
Not
Okay.
on
If
launch
not,
day.
not on
If
launch
it-
day will be the Saturday and Sunday before registration on Monday.
If it doesn't work, we'd be able to use one of the provided launch systems, right?
Yes, you will be able to, but I'm questioning that key switch. Is that key switch supposed to also arm the electronics on the rocket?
Here, could you hold it?
No, I
No,
don't think
the-
so. This is just for the launch.
Yeah, the key
That's
switch.
just launching.
Yeah, all the key
Okay,
switch does is allow you to progress further.
Okay, I'm not worried about the launch box. I just want to know how are you guys gonna arm your rocket on the pad?
So we don't have a there isn't a like switch that toggles power to the board, but the actual connection between the battery and the board itself is what we were gonna unplug and connect.
So when you get out to the launch pad, it's pretty much everything's connected, and only thing that's going to be inserted into the rocket on the pad is your motor igniter.
Correct.
Right.
How are you gonna quickly switch without connecting batteries in the eBay to arm your battery in the vertical position on the pad?
How long does the
I
rocket
don't
sit out on the pad? Like, what's the time from the last moment we could prep the batteries and connect everything? Is that too long?
Everything needs to be prepped and ready, safe in a safe mode, right before the last final inspection of your rocket before you even get out to the pad.
Hmm.
Okay.
You cannot. Only thing you're doing on the launch pad is switching a key switch, a screw switch, or any type of other switching, inserting your motor, your igniter in, and walking away until
Okay.
it's your team's time to launch.
Mm.
So,
I think our plan was to
can't
get
have. You gotta find a way to insert a switch into the switch band on the coupler that will turn on all the electronics, which will be your Telemega, Easy Mini, and your Featherweight GPS.
Okay.
You can make 3 key switches. You could do 1 key switch per electronic,
Mhm.
or try to find a way to wire them all together onto 1 switch.
Okay. Okay. It's better
If you
then.
don't have a switch by launch day or safety review, you won't get the green. You won't get a sticker saying you're ready for launch to prepare for launch Wednesday through Friday or Saturday.
Okay.
If you don't
guess
get the final say so on the convention days of the safety review, you'll have to go through remediation safety review at the VLA at Spaceport America.
okay. For launch dates, is there a way to know which day we are launching?
First come, first serve.
Okay. So is
So
that based
whoever's
on,
prepared, it's
Sorry.
however you guys are ready to go Wednesday, Thursday, Friday, or Saturday. I
Mhm.
highly advise you want to launch as soon as possible. Last year we had a team get mad that they waited till Saturday to launch. They recovered their rocket after the time that post-flight recovery closed to count scoring. So they lost points for not having a score in for their flight.
Okay. And this has nothing to do with early registration. That's separate? Okay.
Early
Okay.
registrations, let's make sure we can just verify people's AAA cards,
Mhm.
name, and get their badges ready for them. So just here's all your badges, here's all your gear. Go set up your poster table. Go
Yeah.
do safety review.
So I had started pre-registration and paused to focus on the technical report, and then I saw a notification that pre-registration is closed. So does that mean we're kind of out of luck until we arrive in New Mexico? Or can I still submit the stuff?
I know they're still submitting it because I just got an update today that another team submitted their pre-registration form.
Okay.
You could try still uploading it. If not, you could email the general SR email regarding pre-registration, and someone should contact you about that.
Okay, I'll ask. I like, collecting waivers takes some time, so.
Correct. And then
we need to fill
you guys ordered your CTI M3400 through Animal Motor Works, and then you plan to have that handed over to you guys at the convention center.
Yes, and I've tried contacting them. I think I talked to you about that. I talked to someone, oh no, I talked to our flyer record about that. I've tried contacting them a lot, and I only recently learned that Gloria passed away, who was part of the
Yes.
Gloria Robert duo. So way back at the beginning of the year, I think when she was still alive, I talked to Robert. I don't know how they are functioning now. I presumably they are still the one of the, sponsored motor vendors at Spaceport, which they were
Mhm.
advertised to be at the beginning of the year. I've struggled a lot to get in contact with them, so I really hope it's going to be easy. I'm going to keep trying. I've called and emailed, but if there's a better way to get in touch, I would really like that.
So Animal Motor Works is a mom and pop rocketry
Yeah.
shop. With Gloria, it used to be a 3-person business. Now it's a 2-person business. They're really swamped.
Yeah.
What
I can
I've heard,
imagine.
Animal Motor Works and another motor vendor, which is
Mhm.
also a ESRA sponsor that we tell students to go through.
Yeah.
They're setting up a rocket motor building like seminar where
Okay.
teams could go to, I think, the Holiday Inn Express in Las Cruces in their conference hall to like get help building their motors.
Yeah.
I would also email the general SR email or the HeroX forum regarding if the motor vendors will be doing what dates and times of motor vendors will be doing their motor building seminar for teams to go get help building their motor.
Okay.
Especially with being a first year team, building a motor could be challenging.
Yeah, we have
Because most of
no
the time,
experience with that.
yeah, most of the time, the issue that makes the rocket go Kato is the motor.
Gotcha.
Yeah.
Yeah. Okay, yeah, I spoke to Gloria over the summer and she was great to talk to. So it's quite
Yeah, I think
sad.
she passed away like in September or like late September, early October.
Okay. Well,
What
I will also, I guess, in the email asking about the seminar, see if they have information on when or where there'll be handoffs. Because presumably there are other teams that have bought motors early to get them in New
Oh yes,
Mexico.
most teams have bought through Animal Motor Works or the other motor vendor.
Okay.
Usually, if you haven't picked them up before launch day, they will have them out at the or the VLA Wednesday.
Okay.
And you could build your motor at the VLA if you want to. Also, if you're a very new team, I suggest trying to get to the seminar to have
Yeah,
experience of building a motor from an experienced rocket builder.
definitely.
Matthew, your switches, do they have to control power to the boards themselves, or can they enable connectivity to the recovery charges? The switches will be controlling the boards themselves because your E-matches that will set off the charges are connected to the telemega that will send the impulse to detonate your E-match. So technically, the switches will need to be powered to the devices themselves that will complete the circuit to power on the board before you get it to the pad. Okay. Ooh. That's a good question. Let's look at the DTAG. Usually we never had teams want to do the switch between the E match and the Telemega. Switches. 11.6. Give me 1 second to call the director of operations or competition operations.
Okay, thank you. In this moment, I'm getting some more.
It's just a fountain, right? There's no container.
Oh.
Oh, you have a container, okay. I'm gonna set up, just-
What are you gonna do?
I'm gonna set up a new meeting,
Already?
just in case. Actually, no, I don't need it.
Do it when it gives us a 10-minute warning.
And my phone's gonna die.
Do you need a charger?
Do you have one? Okay. Nice.
And wait, let me give you my pen card so you can get back in.
Yeah.
It doesn't work for that, it works for the source.
It's good stuff.
Yeah, that's why I thought I was locked down.
Okay, so it's highly recommended, Matthew. You put the wire switch or the switch between the battery and the board. The whole purpose of the switch is to make sure there's no power to the board at all while at safety review at the VLA.
Okay.
I know it's gonna be more work to rewire everything, but that is the safest option to make sure there's no deployment of the ejection charges around people of ESRA and other teams.
Understandable.
And your payload is just a boilerplate, correct?
Yes, made out of rice.
Okay, perfectly fine.
Okay.
And Matthew, you could use any type of switch you want. You could use a key switch, which I personally think they're atrocious looking on the outside of the rocket, but a lot of teams use them. You could use a screw switch to screw in the screw to make sure it's making connections to each side. My team and myself usually use like a switch where you have to use like a flathead to switch it to the other section. All up to you what you want to use in the team.
Okay. Thank you.
No problem. So I feel like we already done the propulsion section / FinCan. We know it's fiberglass cots. We know the attachment point is through the wall.
Mhm.
No tip to tip, but you guys are doing exterior fillets. Your fin flutter quickly. What are
Yes.
your calculation on the fin flutter?
Let me pull it up because
Okay.
we've had a lot of trouble calculating it. The software we used kept crashing.
we were using FinSim 10.
Okay.
Do you do you know the story behind
This guy's interesting.
I forget his name, but we were using the it wasn't the newest version of FinSim 10. It was some different
Pirated.
version because we got it from Ilia.
Basically, best fin flutter software that I could find online was owned and blocked by a guy who didn't believe in the internet. And so you had to email him and he would give you permission for it. And I emailed him and he never got back. But one of our friends who was like our student mentor was like, actually, I have a copy of it. I don't know how he got a copy of it. So he gave us a copy of the software that we're technically not supposed to have because this guy doesn't believe in the internet. His website's really kind of interesting and weird, but he apparently makes good software.
Yeah, point is we got it, and then we did the calcs through that.
Okay, so fin flutter analysis. Okay, fin flutter velocity is 1,114 feet per second as a minimum.
You said 1,114? That's actually pretty good. I got 1,115 feet per second.
Okay, I had no idea. I don't know what the range is, and I didn't know if that was a good number or not.
With a safety factor of 50%, that's the max safe speed.
Okay,
On the flutter boundary speed I got was 2,230 feet per second.
for which
Can
aspect?
we go over your fin geometry quickly to make sure
Yeah.
it's up
Yes.
to date on my end?
Yeah, let me pull that
I
up.
actually don't use like the fin flutter software you guys have.
Okay.
I somehow ended up with a really nice Excel spreadsheet, which I was told not to give out to anyone.
What is it with this stuff?
Yeah.
Because with my own level 3, I had to do the hand calculations for everything.
I like
So,
using
yeah.
Excel. I like making Excel calculator wizards that
There's an Excel sheet that does your fin flutter for you.
Yep.
so we'll have to learn how
That's-
to do that.
That's pretty neat.
My team's made a MATLAB code, and it's still not as good as the Excel spreadsheet that we found.
You
Huh.
found it?
Someone found it, and then we can't find it ever again.
All right, we're
So
gonna have to
if you have a copy, we were told don't give it out to anybody from Esra as well. Like, okay.
That's so
I'm
bizarre.
putting this in my notes. Try to make
Excel fin flutter sheet. That's cool. That's cool.
yeah.
So what's your thickness?
0.193 inches.
Root chord is 18.189.
No, I have here thin tip.
Nah, that's not right. Here, let me get the ruler out and measure the root chord for you.
That's not good. Also, meeting will end in 10 minutes. We'll make another meeting in a sec.
Yeah, where is the apogee ruler? I put it down. So
Hey,
So,
I
okay.
gotta take off. Sorry. I had something at 7, but let me know if you guys need anything from me later.
If you're fine after this, we're going to just have a quick useful information for you guys
Okay.
before competition.
Yeah.
Sure. Okay. Well,
you.
thanks. I'll see you guys later.
Connor, do you want the root chord as it stands out of like from exterior of the body tube to the tip of the fin?
Yes.
That's 6 inches, a little over 6 inches.
So I think this is.
So that should be your semi-span.
Yeah, it's
What they use measure.
6.4. That was
Yeah.
6.417 inches. And then
Correct.
in
Your
the
root
sheet,
chord should be from the leading edge to the trailing edge.
Yeah.
oh. So the information on our final technical report is incorrect. 18 does sound correct then.
There's a foot and
The number you have is.
yeah, it's
correct.
actually exactly 18.
Okay.
Yeah.
Then your
One-
tip chord, I have 3.5 inches.
Yeah, so for some reason, in our technical report, we only have the tip cord, which is a 3.5 inches, and we don't have the 18. I'll put the 18 in our end, but the submitted version doesn't have the 18.
Yeah.
Okay. And then do you know the altitude at maximum speed?
Let me check.
I was pulling the data off of the open rocket graph.
Okay,
I have 1,438.76 feet.
one, as the altitude?
Yes, the max velocity.
Wait,
Search up.
no, wait, I'm just gonna look through, because I don't know what way I phrased it here.
Oh, okay.
Maximum velocity I have as 1058 feet per second.
Well, I need the altitude though, at that
Yeah.
speed.
Connor, what did you say the number was? Search up.
I got 1,438.76 feet.
We don't have that number in our technical report. I would check our open rocket for that value.
Yes.
Okay.
But our open rocket, did you make an open rocket of our rocket, or did we send you a file? I don't remember.
You guys sent me a file and I ran my own calculations on my end.
Oh, okay.
Gotcha. So let me open ours and see.
But at the same time, I don't
Um,
know if I had the updated version from you guys.
That's fair. We did have to change a few things. I don't remember when did we send you our file?
I think the most recent one I have, let me double check. Is from January 7th. Let me check report 2. I do have an updated one from February 25th.
Okay, so I think we might have updated it since then.
Okay.
Our altitude at max velocity. I'm not sure how to see that actually.
You'll go to flight simulations.
Mhm.
Choose a simulation that you're using
Yeah.
for all your information. Go to plot/export.
Mm-hmm.
You just want altitude and vertical velocity. Plot
Ah,
that.
I see it.
And then you want to pretty much hover over max velocity. So you want to zoom in to that orange point. And it looks like I have on my end max velocity,
Let me get this.
altitude. Is now 2,312 feet or 0.05 feet. So let me update
still-
on mine.
Trying to figure out, I see, oh, maybe you have to zoom in more. Yeah, I'm seeing a 2,000. It's not telling me what I'm hovering over it and it's only telling me that of the velocity, not the
So
actual
if you
height.
now at the peak of the orange line, you want to
Mhm.
now shift over to the blue line at that point.
I see. Yes, I see about 2.5. Let me zoom in more.
Okay.
Okay, so here, oh, it's almost 245, 2,450 approximately with a few feet. 2,456 is what I'm seeing.
Okay.
Mhm.
Let me 1 second, put that inside my Excel spreadsheet.
Yeah.
And Matthew, if you have to go, you could go. I'm pretty sure Zeno and Kayla and Owen could talk to the team about the information we'll talk about after
Yeah.
you leave.
Okay, well, in that case, have a good night, y'all.
Have a good flight
You
and have
too.
a good trip.
See you guys.
See you, man.
So your max safe speed should be 1,132 feet now. Your simulated max velocity on my most updated open rocket for you guys was 824 feet per second. What's
Our
your
max,
max velocity
our max
now?
velocity is 1058 feet per second.
What was that?
1058.
1058?
Mm-hmm.
But you guys are still under 1,132, so you guys are good to go on your fin flutter.
Okay.
Great.
So
Yeah,
your
I think
fin,
the
fin flutter's
yeah.
in. Your motor tube is also carbon or fiberglass, correct?
Correct.
Your motor retention is also COTS, which is good. Rail buttons, good. No boat tail.
No.
So you guys can stop recording now.
Okay.